Hi everyone and welcome back to DevPortal, your go-to channel for mastering Java and tech concept. In our today's video, we are diving into thread synchronization in Java, an important topic that will help us to prevent from data inconsistency when multiple threads try to access the same shared resource. So first, let's discuss what we are going to cover today. First, we will try to understand what is a race condition and we will see what impact it will create, and then we will see how we can use synchronization method and synchronization block. Along with this, we will see how we can implement static synchronization as well, and then we will discuss some key difference between Thread.sleep and Thread.yield method. So let's start our today's tutorial. So what is a race condition? A race condition occurs when multiple threads try to access the same shared resource at the same time, leading to unexpected behavior or inconsistent result. Let me give you an example. Suppose you have a bank account where you have an initial balance of 100 rupees and you have initiated two transactions to withdraw 80 rupees from each of the transaction. Ideally, what should happen for one transaction? You should be able to withdraw the 80 rupees amount and you will get a left balance of 20 rupees, and for the other transaction you should get insufficient balance because you are asking to withdraw 80 rupees but ideally you have 20 rupees in your account. But if we create two threads and both threads try to withdraw the amount at the same time, and if both reads the amount before any deduction occurs from the balance, in that case we will be able to withdraw the amount which is not present in my account and we will be able to succeed with both of the threads. Let me show you with the help of an example. As you can see, already I have created a class that is bank account, and inside that class I have created one instance variable that is balance. You can see it here, and I have initialized it with the amount that is 100. After that, I have created one method that is withdraw method that will withdraw the amount which I am asking to withdraw. It will check that amount is less than or equal to that balance or not. If it is less than or equal to, in that case deduction will happen and I will minus the amount from the balance. Otherwise, I will print insufficient balance inside my else block here. Now what I will do, I will create two threads T1 and T2 and I will provide the task that is to withdraw 80 rupees, and we will see it is printing inconsistent balance or not, or either we will be able to withdraw the 80 rupees from each of the transaction. Let me show you. So first let me create a variable of bank account. So I will write bank account and let me give this a name, suppose account, and I will write here new bank account. And now what I will do, I will create one task to withdraw the amount that is 80 rupees. So I will write runnable task is equal to, and here I will use lambda expression, and I will write account dot withdraw, and here I will try to withdraw suppose 80 rupees. And now what I will do, I will create two threads, thread T1 is equal to new thread, and inside the constructor I will pass my runnable task that is task, and let me give this thread a name, suppose thread 1. Same way I will create another thread, thread T2, and I will write new thread, and same task I will provide here as well. It will ask to withdraw 80 rupees and I will give this a name, suppose thread 2. Now to start the transaction, what I need to do, I need to call T1.start and T2.start. So I will write T1.start and then I will write T2.start, and after that I will sleep the main transaction, or you can say main thread. For that I will write Thread.sleep so that we can print the final amount later after 5 seconds. So to print the final amount I will write sysout statement here, and I will print final amount is, and let me print the amount here. I will use account dot get balance. So here what we did, we created two threads and we assign a task to withdraw the amount 80 rupees from each of the thread, and we are checking. Then what we did, we have sleep the main thread that is for 5 seconds, and after that we are printing the final amount and we will end up with the negative amount. So let me run this code first. So you can see in the console it is printing thread 1 is withdrawing 80 rupees and thread 2 is also withdrawing 80 rupees. And for the thread 1 new balance is 20 and for thread 2 new balance is minus 60 and the final amount is minus 60. So here what happened, two threads that we have created T1 and T2 read the balance before either one of them could update it in the balance value. So this is leading to inconsistent result, or you can say inconsistent calculation, and we will end up with the negative amount that is minus 60. Ideally it should be 20. So to overcome from this problem we need to use thread synchronization. This will ensure only one thread will be able to access this critical resource at a particular point of time. What synchronization will do, it will allow only one thread to access that resource and other threads will go into the blocking state until that resource is not free to use. Let me show you how we can do that. So first we will see how we can use synchronization method to overcome from this problem. To make a method synchronize, I just need to add one keyword, that is synchronized, before void. Here after public I need to add synchronized. Execute this method for one thread, we will get insufficient balance and the final amount we will get, that is 20. Let me show you. Let me run this method first. And now you can see in the console it is printing thread 1 is withdrawing 80 rupees and the new balance for thread 1 and the end it is 20, and for thread 2 it is went to the else block and it has printed insufficient balance and the final amount which we got is 20 rupees. So this is how we have overcome from the problem of data inconsistency. We have created a synchronized method that will allow only one thread to access the method at a time. Other threads will go into the blocking state. If you don't know what is blocking state or what are the different states a thread will go through during its life cycle, then you can watch my previous tutorial. Suggestion you can see on top right corner. So this is all about synchronized method, but instead of synchronizing the entire method, we can synchronize only the critical section inside a method as well. Let me show you how we can do that and what benefit we will get. So first let me remove this synchronized from the method level, and now what I will do, I will create one synchronized block here. So I will write synchronized, and what I will do, I will provide my if else condition under this block. Let me save and run this code and we will get the same output as well. Let me show you. So in the console you can see it is printing thread 1 is withdrawing 80 rupees. Then for thread 1 it is printing the new balance is 20. Then for thread 2 it print insufficient balance and the final amount is 20. What benefit we will get by using synchronized block over synchronized method is that it will improve performance as the non-critical section of the code now get executed in parallel. It is not waiting for the method to get free, and it will also provide more precise locking as well, that only lock will acquired on the critical section of the code and the other section of the code will get executed. So this is all about synchronized method and synchronized block. Now let's discuss what is static synchronization and why do we need that. If multiple threads try to access the static method that modifies static variable, in that case we must use static synchronization to prevent ourselves from race condition. Let me show you with the help of an example. So what I'm going to do, first let me remove this code and I will create again one more class here. So let me remove this class first, and here let me create class counter, and here what I will do, I will create one static variable. So I will write private static int count suppose, and I will create two static methods here. First one will increase the value, second one I will use to print the value. So I will write public static and return type will be void, and let me give this a name, suppose increment. And what I will do, I will just increase the count value here, count by 1, and let me create another static method, that is public static, and this I will use to print the count value. So I will write get count and it will return count value to me. Now what I will do, I will create one task that will increase the current value of count by 1000 times. So let me write runnable. Let me give this a tab space first, runnable, and let me give this a name, suppose task is equal to, and here I will use lambda expression. And now let me write for loop, and inside that for loop I will call this increment method. So I will write for int I is equal to 0, I should be less than 1000 times, so that this loop will run 1000 times, and I will call counter dot increment, so that this will end up with the race condition when we will use two threads. Now let me show you how. So let me create thread 1 first, thread t1 is equal to new thread, and here I will pass my runnable task, and let me give this a name, thread 1. Same way I will call thread t2 as well, is equal to new thread, and here as well same task I will provide and name will be thread 2. Now let me start this thread first, t1 dot start, and same way I will call t2.start. And now what I'm going to do, I will write one try catch block here, and let me catch the exception first, and I will complete the catch block first. I will write sysout statement inside catch block, and inside my try block I will call t1.join and t2.join, so that I no need to write thread.sleep. And now finally I will print sysout statement to print the final counter value. So I will write final count value, and I will call counter.getCount. Let me run this code. So you can see it here, we got 1591. If I run it again, you can see 1198. If I run it again, 1246, 1225. Ideally we should get 2000, but we are not getting that because of race condition. So to overcome from this problem, we need to create this static method as a synchronized static method. So let me add synchronized keyword here, and now if I try to run this code, we will get 2000 as an output. You can see if I run multiple times, it will print 2000 every time, because one thread will be in blocking state until this method is not free to use. So this is all about synchronized method, synchronized block, and static synchronization. Now let's discuss what are the key difference between Thread.sleep and Thread.yield method. So let's start with Thread.sleep. What Thread.sleep will do, it will pause the current thread execution for a specific amount of time that we have mentioned. Suppose if I write Thread.sleep 2000, in that case my current thread will go into the timed waiting state for 2 seconds. But it does not release the log if it is under synchronized block. If we talk about Thread.yield, in that case what it will do, it will suggest the scheduler to pause the current thread and give CPU to another waiting thread. But it does not guarantee that the thread will yield immediately. It just tells the CPU to switch execution to another thread. If we talk about the key difference, what Thread.sleep will do, it will pause the current execution, while Thread.yield suggests CPU to switch execution to another thread. With Thread.sleep, there is a guarantee that the execution will get paused, but with Thread.yield there is no guarantee. And in both of the cases for Thread.sleep and Thread.yield, the lock will not get released. So this is all about thread synchronization. To summarize, race condition occur when multiple threads modify same shared resource simultaneously. And to overcome from this problem, we have used synchronized method that will prevent multiple threads from executing the same method at same time. And we have used synchronized block as well that will provide fine control over synchronization as well over synchronized method. And we have seen how we can use static synchronization as well that will prevent race condition in the static methods. And then we have discussed the key difference between Thread.sleep and Thread.yield. So that's it for today's video on Dev Portal. If you found this video helpful, make sure to like, subscribe and hit the bell icon to stay updated with us. Notes link I will give you in the description box as well as in the comment section, so you can check it out for your learning purpose. In the next video, we will explore logs and atomic variable in Java. So please stay tuned, and I will see you in the next video on Dev Portal.